So at the summary step, you also have a QR code, which also has a Toyota code. I'll just run that for a while, and you can actually go to the dealer with your QR code and let the dealer scan it in within an application on his iPad, and the exact same configuration as the car you configured will get loaded into this iPad application. So internally, the iPad application also runs the car config. So up onto the next slide. So this is a small technology overview. So we started with the first car config, which was actually Lexus, the V4, building it purely in Flash. That was mainly done using ActionScript. Much later, we also did the Toyota Flash car config. And then, of course, mid-2012, we got the request to get the car config on the iPad because it was very popular. It is still a very popular device. But of course, considering it was Flash and Flash didn't run on the iPad, we had to come up with a specific solution. So that was the first time we built a big application for the iPad solely in HTML, JavaScript, and CSS. And then, of course, as of 2014, we developed the V6 HTML car config, which is built mainly using React. So here are some screenshots of the V4 Lexus car config through the Flash. So the V4 Toyota car config. As you can see, a lot of the components look kind of the same. So basically, it was a shared code base. And this is the V5 Toyota car config, which was mainly built for the iPad. Then, from the beginning on, we decided to split up the user interface. So from the beginning on, I mean, when we created the first car config using Flash. So we decided to split up all the business logic and also the web server communication as a separate JavaScript file, which we currently call the JavaScript controller. So all the business logic and the user interface would be completely split up. This has proven to be a very positive way of developing, because even up until now, throughout all the car configs we developed, we still use the same principle. So yes, so I'm not sure if everybody understands what business rules are, or should I dive into it a little bit? So basically, the business rule is when you select a specific color, you say to the controller, set exterior color, and then the controller takes care of those rules. And for instance, if you had a specific interior selected, the controller will say, oh, the interior is not compatible with that exterior color, so it defaults to another one. Same goes when you select a specific option. You say to the controller select me that option, and it will go through the include rules and perhaps select another option with it. As you saw in the demo, for instance, if you select the roof box, it'll automatically also select roof rails because, well, one can't go without the other. That's all the responsibility of the JavaScript controller. Of course, if the JavaScript controller doesn't have enough data at the moment, at the moment he needs it, a web service call is also made to get all the data he needs to resolve all the business rules. Okay. So we had the V4, which was built in ActionScript, using Flash, of course. Then we had the JavaScript, the V5, which was utilizing the J library. I tell this because I have some code examples coming up, so it's handy for you guys to know that J library is actually an in-house developed library, which is very similar to jQuery. And of course, the current one, the V6, is using React. So with the Flash car config, we had a specific development process that we had the design guys design the application purely in Photoshop templates, and then we just take those templates and start developing with it right away. So we would actually implement based from the Photoshop files. As of the HTML implementations of the car config, being the V5 and the V6, we basically have the design team who design of course, Photoshop files. Then we have a template team, which does a heavy template lifting. So they already slice everything up and put it in the corresponding nodes. And then we have where me and another colleague of mine come in, and we take those templates and we create components out of them. So make everything dynamic. So, it's not so bad. Yeah, but I don't think anybody can read it. But I wanted to show a little bit of a comparison.
He's a developer.
I wanted to show a comparison about how a component class looks like from Flash before up until React v6. So I made some images. So first of all, this is the class definition of a component in Flash. So we have projects class action. I'm not sure if everybody can read it, sort of. Well, I'm not sure if it matters that much, but at least I'll try to explain. And then you have JavaScript using the J library, v5. You have basically what we do is when we create components which are reused on a lot of steps, like interior step, interior step, we create a namespace which is a chain of objects. As you probably won't be able to read, the first declaration is var UI equals be.marlin.ui, which is our working namespace. Then we declare a new function on it, which is ui.info, which will then get instantiated as soon as we need it somewhere from a specific component or step. Then, of course, in React, a similar approach is used as in the v5 car config. So we still have our closure function within the file and our global namespace where we define the component on. But of course, you have to create class from React. Then here I wanted to show the difference between the public and the private functions. So in Flash, you have as simple as that, public function, private function. In JavaScript, we define public functions on this object. So within your function declaration of your component, as might be seen here. So within this scope, we define this.show is a public function which you can call on, for instance, input. Private function is then just a name function within the scope of the component itself. In React, there is no really difference between public and private methods. We just declare them all within the React create class method. It's just a matter of semantics or rules between each other, but there's not a real difference. Then, of course, one of the most important things in React is the render method, which is also one of the most beautiful things about it. So in Flash before, almost everything was drawn by code. So I don't have to tell you to be able to get an idea of how the component looks like. You'll have to have a very good knowledge of ActionScript and how to draw dynamically in ActionScript using code, of course. I mean Flash, not ActionScript, but you get the idea. In JavaScript, we use the J framework. So on a similar manner as in the before, we also created a lot of the div classes in this case, or HTML DOM nodes dynamically. But as you can see, this is just a chain of element creations, and it isn't really clear of what that'll produce once in the DOM or once in the shell house. Then, of course, in the v6 we have the render method, and that's a very beautiful thing about React is that it's almost a one-to-one representation of what you will be seeing when you inspect the specific node in your developer console in the browser. So, yeah. So, the React components we write are written in JSX files. to get from GSX files to JavaScript files. Of course, we have a specific development workflow. We use Grunt as an automation script / task runner. We use Bower as a library manager, as the Grunt plugin. And we use Grunt React, of course, as a GSX transformer, get from GSX to JavaScript. We basically have one static folder which contains all our sources, and all changes done to files are of course done in the source folder. And then we have the Grunt script, which takes care of generating the build and the deploy folder. So basically what we do when we start developing is we run the Grunt task, and the Grunt task runs the startup flow, and it takes care of these individual subtasks. So first it does these libraries, transform GSX to build JavaScript, then copy source JavaScript, because next to GSX files we'll probably also have regular JavaScript files, and then compile SAS to CSS, all done in the build folder, and then it will start a watch task. The watch task is optimized to keep an eye on the files which have changed. So if you're developing in one specific file, you save it, it detects the one specific file change, and it executes the appropriate task on it. So if you're working in a GSX file, it just will compile or transform the GSX file to JavaScript in the build folder. So as I already said, all development is done in the source folder, but you run against the build folder. And then when we want to go to one of those environments and eventually production, we run the deploy flow, which executes the startup flow, generates the build folder, and minifies and concatenates JavaScript CSS. What happens. And everything gets generated in the deploy folder. Next to that, one thing which I also very much like is it also generates source maps. And source maps itself help us a lot to debug specific bugs which were tracked down in production or suddenly popped up in production. So source maps is really handy.
Maybe they don't know what source maps is.
Does anybody not know what source maps is, or everybody knows what source maps are? Okay. All right. So then in the V6 we used mostly these libraries. So we use ReactJS of course for our component, and I use the interface design. Then we use jQuery for animation and smaller DOM manipulation. We use Lodash as a utility library and Postal as an event emitter. I'm quickly going to dive into the code and give you a lifecycle example. So in order to do that, I quickly sketched how our component structure is. So we have one big car config JavaScript file, which is the first file which is loaded and also renders and instantiates the entire car config basically. So that file contains top container, middle container, and bottom container. The containers are created based on their location in the page. So perhaps if you remember a little bit from the demo I showed in the beginning, top container is everything above the navigation, the middle of the container only contains the navigation, and the bottom container is everything below. So the top container is, for instance, the exterior step, the interior step, and the bottom container is then the filter step, but also the specification sheet you see what is on the exterior step, for instance. Next to these three main React components, we have the controller who takes care of the business rules, and everything, all communication between the React and the business rules is handled within the car config.js file. The top container, as I already said, contains an exterior React component, which represents the exterior step. And on this turn, it contains an H list, which is also a React component for rendering the colors, the wheels, and the options. The H list, in the context of the car config, is a really common component because it's used very much throughout the car config. And so it was, for me, rather a good example to start on. So, another screen cap.
Hopefully this goes a little bit better.
Yes, it does. So here we are at the exterior step. All right. It's counting on my screen, but it isn't progressing on that one. So, all right. Perhaps I could just. So we were at the exterior screen, and I predefined some breakpoints in the code as soon as you click on a color. So when you click on the color, you get into the, just take my mouse with me, you get into the item click handler, which is defined in the H list for JavaScript. So the item click handler is a handler which is defined on a list item, which is part of the H list, of course. And the list item has a click handler which propagates all to the H-list click handler, which is defined in the render method, as you can see here. Touch click handler is some wrapper to support touch devices a little bit better, but it boils down to the same principle. So also, the click handler in the H-list triggers a specific method on the controller. So, for instance, if you have an exterior H list with all the colors in, you pass in the set exterior color handler. If you have the wheels, you pass in the set wheels method to the H list. So that specific controller method gets called upon clicking one of the items. So as you can see, in this case, you go into the set exterior color method in the controller.javascript file, and this is the part where all the business rules get handled. After everything has been taken care of, we get into a kind of centralized function within the controller, which dispatches the configuration changed event. This event is then tracked and handled within the car config.js file, which is the main file which runs the car config. And as you can see, an event handler is added to the controller instance. And in the event handler, the specific containers get updated with a new configuration object. So we have a principle that in the controller, each change to the configuration object emits a specific change event. So it's only within the controller the configuration object can change. And it always gets handled within this handler. So we have a unified flow of how changes in the car config work. So then we get, of course, in the render method of the top container, you can see that the configuration object gets passed through to the specific steps, exterior, interior, and support, and so on. Then it gets into the exterior step. As you perhaps could not see the exterior colors list, it might clean that up a little bit, which basically instantiates an H list. And as I'll be selecting right now, it passes through the selected property. Then, of course, as I said in the beginning, the specific controller select handler is also passed through from above. And of course, if we continue with our breakpoints, you can see that the specific color is selected. Then, some pros of using React. Once you get your head around how React works and how you should or can define components, it's very easy to read. One positive point is also that it has an immutable data structure, so it's easy to get to check in your component itself what's this doing well. Sometimes hard to explain that part, but it's easy to compare the previous props to the next props, or previous props to the current props, or current props to the next props, thanks to the immutable data structure. So as soon as new properties get passed through from above on a specific property of the props object, you can check by just comparing specific objects or the specific properties in the object. So then, next to that, of course, you have a structured and flexible workflow. If you start developing a very big application using React, you'll find out, if you structure your files a little bit decently, that it's really nice looking. So you have a React component which contains a React component again, again, again. So in the end, you have a pretty nice flow of how your application is coded. It's very flexible. By that I mean is that, for instance, if you already have an existing application, you can start transforming all parts of your application using React, because, well, it's really lightweight and it doesn't introduce any other dependency or libraries. It's just React. It's very fast, which still surprises me up until today even, that if you run through the render method a lot, so a couple of times a second even, then the comparison between the virtual DOM and the actual DOM is done really fast. And last but not least, it has a large community. So if you encounter a specific problem or have any questions, just Googling it might already find the answer. What I also found especially handy next to the render method is the get initial state and the get default props. These are optional methods and doesn't need to be declared at all, of course, if you start from the top level component and you pass through to the bottom. But for large components, I found this very useful just to declare what data travels within your component. If you haven't worked on it for a couple of weeks / months, it's easy to look at the get initial state, the get default props, and the render method to already get an ID or a reminder of how the component worked and start off where you left off. So that's also something which I find very handy. Then, of course, next to the pros, you have the cons, which are by far a deal breaker, but I just want to point them out a little bit. If you have a very large application, and we used to automatically update the React library as soon as a new one came out, but at a specific point, a new one was released, we didn't pay attention to it, and it had some negative side effects. So for instance, perhaps something internally changed, that when we navigated to the exterior step, the order of animations was different because of reasons unknown. So from that point on, we had to fix the version of React to avoid these effects in the future. So that's, of course, something tedious to take into account. If you have a very big application and a lot changes to the React library itself, you have to, of course, be able to maintain all the changes. Then, when you have built a very big application, it's very hard to switch from React to something else. That accounts for a lot of frameworks, but in general, it's also something to take into account. And sometimes it has fake error logging. One of the two most annoying things I found is the no key prop defined and the child with the same key encountered. First one is more like a warning. Second one is something more severe. I included some screenshots of my logs. Yes. So most of the time, these two are not really a problem because you're working always on a specific component or a part of your application. So when you encounter them, you know where to look. But of course, if for some reasons an already deployed version of your car configurator, a user clicks through it and as it's not working anymore, you reproduce the specific scenario and you see this. It's very hard to determine what has gone wrong. The only thing we see is a specific, I think it's the data ID that React gives the specific node, but that's the only thing you have. If you have a very big application, of course it gets populated with everything and you sometimes end up with a very big string. So it's hard to point out. Next to that, you have the warning that each JSX node should have a key prop when put in an array. Of course, looking at the warning message, it doesn't really tell which node should be looked at. And then, final but definitely not least, is the animation. As soon as we started implementing React, we found out that animation was one of the things which were definitely missing from the framework or from the library itself. And the way we manage that is, if you remember in my previous slide, I pointed out that we use jQuery for animation. We also use some pure JavaScript for specific animations. But the way we fix this is we found out that when you define a specific React component, that it only tracks the CSS properties passed through it in the render function. So all other CSS properties you can do with whatever you want. It doesn't track them and it doesn't complain about them. So what we did is I have a small file. So this is a small So this is a preloaded class which we use in the car config, which is a preloader you see when you start with the application, and you see also coming back throughout the configuration process. So we have a render function which basically only contains a div and a div class named image. This specific div has a CSS set to contain a background image, which is basically all the frames on a specific preload. So when a component did mount, we keep a component level reference to the specific div. And then when the animation should start or the preloader should be shown. We come in the set show state completed, so basically the showing and the hiding is handled by React, as you can see in the render method, but the animation itself is handled by pure JavaScript by utilizing a set timeout. So when we show the component, we update, tell the preloaded show yourself, basically. The render method gets triggered, your state update is complete, and then we set an interval. And the interval handler basically updates the background position of the background image. That is done in pure JavaScript, but all other animations are done in a similar manner. Then, some things we have in mind for future improvements. We start using WS, which is basically ECMAScript 6. Implement the Flux workflow. We already did some research about, or tried out the Flux workflow with non-car config related components, which proved to be very structured, and it's very easy. It's very easy to work on an application when it's set up and using the Flux workflow. But it can sometimes be a little bit overcomplicated depending on which component you apply it to. Perhaps in the extent of implementing Flux, have a look at Redux, then using React Router as deep linking. And one thing which I'm definitely a fan of is using GraphQL for data fetching. This isn't really much of a front-end dependency or front-end developer to take care of, but GraphQL basically allows you to define the signature of the data you will be retrieving. So, for instance, if we request specific model data, currently we get a kind of a bloated object with a lot of properties, some properties which we don't really use in the front end. So when GraphQL is implemented, you can say, I want model data, but I only want these properties, and only properties defined in the post method are being returned. Then, of course, to finalize, we are recruiting. So we're still looking for React developers. It's something really popular these days. And are there any questions?
Have you tried React Motion
No.
for animations? Because they presented it at React Europe, and it's getting quite popular. Maybe you should have a look. I haven't tried it, but it looks.
Animation issues.
Sorry?
React Motion for animation to really solve issues you mentioned.
Okay, we might have a look at that. Thank you. Yes.
How about testing this? Are there some dedicated framework for testing?
No. Manual labor, I'm afraid.
Just
Because of. Sorry?
Jest is a testing framework for React. Jest.
Oh, okay. Yeah, I'll definitely take note of that. But of course, if the user interface changes, or animation change, or the flow changes of the car config, everything needs to be tested manually. But we have a set of regression tests, which we do each time we deliver. So we have some sort of testing protocol, but nothing much automated.
In the workflow of building that you explain across the ground and then the task, do you use a module partner? Because I didn't see anything like Webpack browser verify.
Oh, no, we don't use them. Well, we started developing React way before those became popular. So we basically started off from that point. So that's the same reason why it's not so easy to start integrating a specific animation framework, because the way we do animations is so incorporated in the entire application that it's not so easy to determine like, yeah, let's try out a new framework or a new library and make sure that everything still works, because there's so much going on throughout the configuration process that it's not so easy to keep everything updated.
Let me ask you, how, when you have two components and one needs the other, how do you import statements? How do you different required JS, or how do you do that one?
Everything is,
Lives in the global scope.
yes, all components which are reused on specific steps live in the global, global space, yes. But perhaps as you might have seen in the H list, the GSX example, currently it also contains a list item component. And that is only contained within the closure scope of the H list, because not all components need to know about it, and it's only used in the H list itself. It's just for semantic reasons and get a more overview of the component itself that we split it up, but it's still contained in the same file. So,
One more question, because then we've got, I've got to speak, for God's sake. Did you take one more question and then?
it's all the same to me, yes.
How much of the car parameters do you handle client side versus do you push everything back to the server? So meaning that if I change the color on an option, do you push everything back to the server and computing everything for the car parameters and sending it back, or do you do something on the client side?
Very good question. Everything prior to the exterior step is handled by the server. So if you select a specific grade, engine, model, body type, a compatibility check method is called to check the compatibility, logically, and a specific configuration object is returned which is compatible. Everything after the exterior step is handled client side. So if you select a specific color, it's that exterior color, and all the business rules are handled based on the data which is retrieved for that specific step.
Do you track the analytics of the color selected for example, or not?
Yes. So analytics are of course part of the application. One last question.
And just interrupt, how do you guys manage the version of React? Because, every now and then you have there is, and you guys just upgrade or?
No, we currently fixed, ever since we got the problem where we used to upgrade gradually when a new React version came out, but then we had some new problems. We managed, we decided to fix it at a specific React version. It's a little bit to the same extent as implementing a specific new way of doing animations or whatever, because sometimes it can be very, how would I put it, very work intensive to update all code to match the new specifications of which React dictates.
Which version are you using?
I'll tell you privately. So anyway, thank you for listening. And,